Alright, so I'm going to show you how to manually process BAPR files and be able to look at each individual slice and so on before they're added together. So I open up the NUTS program and open your file first. File open, and that is 600 megabytes or something, it looks like. Before we start doing any processing, this is an array of data, so we have to enter arrayed mode. So down here in the bottom left hand corner, I'm just going to type the command AR, and if you look over here in the bottom right hand corner, you'll notice that it says now complex arrayed, so that we're in arrayed mode. That means anything we do to the one that's currently on the screen happens to the whole array. So first we're going to do is check the line broadening value, which I think you were using 1, but I'm going to use a value of 2. And I'm going to use exponential multiplication in conjunction with that line broadening value. It's going to take a while because it has to go through all 500 or 1,000 slices that you have. When it's done, you'll see it appear on screen. I'm going to try to zero fill this data. I'm not sure if we can. Insufficient memory to perform zero fill. Okay, we can't do that. Next we will Fourier transform, FT. It takes a while because it's going to have to go through and do all of them. There's the FT spectra. Next thing we want to do is phase, so first I'm going to zoom in on it, and then we will enter phasing mode. And I'm just going to go into mouse phase, phasing by mouse. You notice that the phase values are up here, and the pivot point is way to the end of the screen. If you hold the mouse at the leftmost peak and type the letter P, that will set that as the pivot point, I believe. Let's see if that does it. Not responding. Let's see why. Oh yeah, there's a pivot point, 32.5 ppm. So this is bringing my computer to its knees, which is strange because it's a pretty fast computer. I don't have a good video card though. So I'm going to phase this. You know, your phasing values should, for the frequency independent, should always be less than plus or minus 180, and it was pointing almost all down, so you see it's minus 156. I'm going to blow it up a little bit more so we can see if we're really phasing it correctly. And there's the phase, and it has to put that on all of them. Wow, that is taking a long time. Let's zoom in on this peak right here and show them all by typing stack plot. You notice they went off the side of the screen. I'm going to type W for whitewash so we can kind of see them a little better. So before we set our zoom region, we want to make sure that they're all on the screen, and I'm just going to use the right or left arrow to move them over on the screen. So now that we have the right zoom region, we hit enter to get out of stack plot mode and enter zoom mode and type the number 0 to set this as zoom region 0. Now let's take a quick look at it one more time. So there's a couple things you can do manually. While you're in stack plot mode, by the way, you can type the letter O for offset and change the offset from 10 to 0. That way everything is supposed to line up straight. You're not offsetting each individual spectra. You can type the 2-letter command R0. The 0 is the 0 you set for the zoom region, and that will line up all the spectra. So now if we go back to stack plot mode, you'll see they're all lined up, one right behind another. There's a separate command, Y0, and that will not only line them up, it will also add them up. So if I'm going to type Y0, and that is currently on the screen is the result of the Y0, and if we look at both of the peaks now, you got much better signal to noise, and I'm not sure what you're looking for in here, but it looks like there's some peaks showing up around 25 or so. Let's set this peak to 0 because this is your phosphoric acid. There's 2 different ways to do it. So you can click in the middle of the peak and type the letter O, and set it to whatever value we want. So that's a nice feature. Let's just set it to 100 just to show you. So now if you look at the bottom, it's set to 100. If it's the tallest peak on the screen and it's supposed to be 0, you can type the command SZ, set 0, and there you go. It's automatically set to 0. So now you can see that we've got much better signal to noise and better resolution than you previously had. And I think the problem was that you did not set the correct zoom region when you added them up the first time.